Example 2. X is a discrete random variable with the PDF function. Firstly, if we have discrete random variable, we can convert into the table. So, draw a row, and the first row represents the X. So, X, we start from 1, 3, 4, 5, and 6. 1, 3, 4, 5, and 6. And the second row is for the probability. So when x equals to 1, we use this function. So substitute 1 into x, so we get 2c. When x equals to 3, we also use the same function. So substitute 3 into x, then we get 4c. When x equals to 4, we use the lower function. Substitute 4 into x, then we get 9c. When x equals to 5, we use the upper function. So substitute 5 into x, then we get 6c. When x equals to 6, we use the lower function. Substitute 6 into x, then we get 25c. The question asks you to find the value of c. So you must remember the important condition for discrete random variable that I have mentioned in the previous video is summation of the probability must equals to 1. So to find the constant c, so we must add up all the probabilities and equals to 1. So 2c plus 4c plus 9c plus 6c plus 25c is equals to 1. And the value of c is equals to 1 over 46. Next question is you need to construct the probability distribution table for x. So we substitute the value of c into the table. So start from 1, 3, 4, 5, and 6. The second row for x for the probability. So substitute c equals to 1 over 46. Then we get 1 over 23. When we substitute c equals to 1 over 46 times with 4, we get 2 over 23. And then we get 9 over 46. But we times 6 times with c, which is 1 over 46, then we get 3 over 23. And then finally, 25 times c, then we get 25 over 46. Hence, find the probability of modulus x minus 2 less and equals to 2. So firstly, we must define the modulus. So it becomes x minus 2 less and equals to 2 and greater than negative 2. Okay, simplify, and then we get 2 plus 2 we get 4, and then negative 2 plus 2 we get 0. We must find probability which is x less and equals to 4 and greater than 0. So look at the probability distribution table. So we can take the value of 1, 3, and 4. So px equals to 1 plus px equals to 3 plus px equals to 4. The probability when x equals to 1 is 1 over 23. When x equals to 3, the probability is 2 over 23. And when x equals to 4, the probability is 9 over 46. We add up all the probabilities and then the answer is 15 over 46. Question number 2. Find the probability exactly 3. Exactly means x equals to 3. So from the table, x equals to 3 is 2 over 23. Okay, question number 3. Find the probability at most 5. So at most mean x less and equals to 5. X less than equals to 5 means the value is 1, 3, 4 and 5. Px equals to 1 plus px equals to 3 plus px equals to 4 plus px equals to 5. When x equals to 1, the probability is 1 over 23. When x equals to 3, the probability is 2 over 23. When x equals to 4, the probability is 9 over 46. And the last one, when x equals to 5, is 3 over 23. And the answer is 21 over 46. Question number 4. Find the probability at least 4. At least means greater and equals to 4. So look at the table. Greater and equals to 4 means start from 4, 5 until 6. So px equals to 4 plus px equals to 5 plus px equals to 6. The probability when x equals to 4 is 9 over 46. When x equals to 5, the probability is 2 over 23. When x equals to 6, the probability is 25 over 46. Find the probability at least 1 but not more than 4. So the symbol is x at least 1 means it must greater and equals to 1 but not more than 4. More than 4, the symbol is greater than 4 but not more than 4, the symbol is reverse and then include 4. So, to find the probability x greater than 1 and less than 4, look at the table. So we can take the value of 1, 3 and 4. So px equals to 1 plus px equals to 3 and px equals to 4. The probability is 1 over 23 plus 2 over 23 plus 9 over 46. And the answer is 15 over 46. Okay, B. What is the probability when x is an even number? Even number, as we can see here, the value is 4 and 6 only. So for when x is an even number, we can take the value of x equals to 4 or x equals to 6. When x equals to 4, the probability is 9 over 46. And when x equals to 6, the probability is 25 over 46. And the answer is 17 over 23. C. Calculate expectation of x and variance x. So remember, formula for expectation of x is sum of x times with the probability. It means you must multiply x with the probability and we start from x equals to 1. So 1 times the probability, which is 1 over 23. 3 times with the probability, which is 2 over 23. 4 times with the probability, 9 over 46. 5 times with 3 over 23. And 6 times the probability, which is 25 over 46. And the answer is 5. Okay. The next question is find the variance of x. What is the formula for variance? So formula for variance is ex square minus mean square. Firstly, you must find expectation of x squared first. So expectation of x means x times with the probability. Expectation of x squared means x squared times with the probability. So we start from 1, square it, then times with the probability. 3 square, then times with the probability. 4 square it and times with the probability, plus 5 square times with the probability. Finally, 6 square times with the probability. And the answer is 616 over 23. So substitute the value into variance formula. Variance of x is equals to ex square minus mean square. So ex square that we get just now is 616 over 23 minus mean square. So mean we get 5. 5 square, then the answer is 41 over 23. Okay. Next, the question asks you to find the variance of y where y is equals to 5x plus 30. Variance of y means variance of 5x plus 30. So remember the properties that we have discussed in the previous video. Okay, if you have constant on x, so take out the constant, square it, then multiply with the variance. And then variance 30 or variance constant is equals to 0. So 5 square is 25, then times with the variance. So variance that we get just now is 41 over 23. And variance y, the answer is 1025 over 23. Example 3. In this example, I want to show you how to find the probability from CDF. By definition, CDF or capital Fx is equals with the probability of x less than equals to x. For example, F3 is equals with the probability of x less than equals to 3. It means the sum of the probability up until x equals to 3. Okay, so Px plus 1, Px plus 2, Px equals to 3. So you must remember that F3 is not equals with the probability x equals to 3. Okay, so look at question number 1. Find the probability when x less than equals to 3. So less than equals to 3, we can write it as F3. So simply we can take the value of F3 from the function, which is 8 over 15. Okay, question number 2. Find the probability when x is greater than 3. Remember, we only can use Fx or capital F when the sign is less than equals to x. So, we can use the number line to help us to find the probability when x is greater than 3. So, draw a number line. So, start from 2, 3, 4 and 5. So what we want is, we want x greater than 3. Okay, open interval, open circle for 3. Okay, because the question don't want x equals to 3. Okay, so we also don't want x equals to 2 and x equals to 3. So we start from F5 and then minus with x equals to 2 and x equals to 3, which is F3. So from the function, F5 is equals to 1 and F3 is 8 over 15. And the answer is 7 over 15. Look at question 3. Find the probability when x equals to 3. So we draw a number line, start from 2, 3, 4, 5. So we just want x equals to 3 only. So we don't want x equals to 2 or less than x equals to 2. So we start from F3 minus with x less and equals to 2, which is F2. So F3 is equals to 8 over 15. And F2 is equals to 1 over 5. And the answer is 1 over 3. Question number 4. Find the probability x between 2 and 5 but not included 2. So draw a number line, 2, 3, 4, 5. So start from 2 but not included, 3, 4, 5. Okay. So we don't want x less and equals to 2. So start from F5 minus with x less and equals to 2, which is F2. So F5 is 1 and F2 is 1 over 5. So we get 4 over 5. Question number 5. Find the probability when x is between 3 and 5, include 3 but not included 5. So draw a number line, 2, 3, 4, 5. So we want 3 and 4 only because not included 5. So we don't want x less and equals to 2. So we start from F4 minus with x less and equals to 2, which is F2. So F4 is equals to 4 over 5 and F2 equals to 1 over 5. So the answer is 3 over 5. Question number 6. Find the probability between 2 and 5, both included. So draw a number line, 2, 3, 4, 5. So we can put 1 here. So what we want is 2, 3 until 5. So we don't want x less and equals to 1 here. Alright, so we start from F5. Then minus with F1. So F5 is 1 and F1, look at the function, F1, which is x less than 2, the value is 0. So the answer is 1. Example 3b. Find the probability distribution function or PDF from CDF. Firstly, convert CDF into a table. So draw a row and a column. So the first row represents the x. So we start from 2, 3, 4 until 5. The second row is for the CDF. Look at the function. F2, 1 over 5. F3, 8 over 15. F4 is 4 over 5. F5 is 1. So convert into a table. So F2 is 1 over 5. F3, 8 over 15. F4, 4 over 5. And F1 is 1. Then draw a next row below CDF. This is PDF. So to find x equals to 2, so we use F2 minus F1. So we get 1 over 5. To find the probability when x equals to 3, we use F3 minus with F2, which is 8 over 15 minus with 1 over 5. Then we get 1 over 3. To get the probability when x equals to 4, we use F4 minus with F3, which is 4 over 5 minus with 8 over 15. Then we get 4 over 15. When x equals to 5, we use F5 minus F4, which is 1 minus 4 over 5. Then we get 1 over 5. Then write your answer in probability distribution function. So the probability is 1 over 5 when x equals to 2 and x equals to 5. The probability is 1 over 3 when x is equals to 3. The probability is 4 over 15 when x is equals to 4. And don't forget 0 otherwise. Example 4. Read the question carefully. A bag contains 4 pieces of red towels and 3 yellow towels. The towels are to be drawn at random one by one without replacement from the bag until a piece of red towel is obtained. X is the total number of towels drawn from the bag and construct the probability distribution table for X. So firstly, we list down the number of towels. So we have 4 red towels and 3 yellow towels. To help us understand this question, draw a tree diagram. So first draw, we could get either red or yellow. So the probability of getting red towel is 4 out of 7. And the probability of getting a yellow towel is 3 out of 7. From the question, it says that we draw a towel from a bag until we get a red towel. So, if we get a red towel, we don't have to continue the process. But if we get a yellow towel, then continue the process. So for second draw, we could get either red or yellow. The towel are drawn without replacement. It means the total space becomes decreasing. So the total space becomes 6. So the probability for second draw for yellow is 2 out of 6 and for red is 4 out of 6. Continue if you get yellow towel for the second draw. Okay. For third draw, we could get either red or yellow. So the total space becomes 5. The probability of getting yellow towels for third draw is 1 out of 5 and red towels is 4 out of 5. Continue the process if we get a yellow towel for third draw. So the fourth draw, we could get either red or yellow. So the probability for yellow towels is 0 out of 4. And for red towels is 4 out of 4. So, at the end of the tree diagram, write the number of towels. Because X represents the number of towels. So here, the total number of towels is 1. The total number is 2. For this case is 3 and 4. So construct a table to represent the number of towels and the probability. So for the first row, we write the X, which is the number of towels. So start from 1, 2, 3 until 4. And the second row is for the probability. 1 means the total number of towel is 1, which is red. So the probability is 4 out of 7. 2 means the number of towels is 2, which is yellow and red. So to get the probability, just multiply along the brush. 3 over 7 times 4 over 6, then we get 2 over 7. 3 means we have 3 towels, which is yellow, yellow and red. To get the probability, multiply 3 over 7 times with 2 over 6 and 4 over 5. Then we get 4 over 35. 4 means 4 towels, which is yellow, yellow, yellow and red. The probability of getting 4 towels is 3 over 7 times 2 over 6 times 1 over 5 times 4 over 4. Then we get 1 over 35. So this table represents the probability distribution table